Hi, I'm Mike Thompson. And did you ever wonder, do you use less gas if you drive faster? Well, I have. In fact, I've used this argument to humorous effect to justify my driving at times. I thought I could get away with the argument that since I'm driving faster, I'm on the road for less time, and therefore I'm burning gas for less time, right? Well, I thought about devising an experiment with a measured amount of fuel over a set distance and actually seeing how much gas was burned. But there's really no reason to do that. All I really have to do is check the math. And so that's what I'm going to show you here is why, in fact, that the defense's case doesn't hold water. So, at high speeds, highway speeds specifically, we pretty much are only concerned with the air drag, which is just related to the shape of your car and some other things. We're going to neglect rolling resistance, which is friction in your bearings and your tires, because at higher speeds, that is much less important than the drag created by the wind resistance on your car. The basic drag equation is the force of drag is 1/2 the air density times the coefficient of drag times the reference area times your velocity squared. The only thing we really have control over is the velocity at which we choose to drive. We don't have any control over the air density, the frontal area of your car, or its drag coefficient. So let's just simplify this for demonstration purposes and call all that stuff 1. And now you can see that force of drag is really just a function of how fast you drive. So if we're given choices of either say 60 miles per hour, 90 or 120 miles per hour, and let's also assume for a second that the speed limits aren't enforced, we can see here if we just kind of plug and chug how the drag increases dramatically if you just double your speed. Since the velocity is squared, your force of drag is going to quadruple. Now, if you have to overcome more force, you need more power. The next line, we can see work is a force times the distance. And if we simplify all this, and power is the rate at which you do work, so if you do the same amount of work in less time, you're going to need more power. And so all this simplifies to power is simply the drag equation, but now we take velocity and cube it. So if we add another column to our table here, we can see that power increases dramatically even faster than the force of drag did, because now it's a cube term. And unfortunately, this is the answer that we're looking for. Since you have to generate more power, you have to burn more gas. So the argument, even though it's somewhat humorous, does not actually work. So I like to measure things, and I just kind of wanted to see what kind of mileage my car was getting at various speeds. And so after several hundred data points, I came up with this graph here. I took into account temperature and wind. I found temperature doesn't really have much of an effect, but wind certainly does. Whether it's a headwind or a tailwind, it changed my miles per gallon by about 10. And so that was really significant. I took the wind data from the local airport, AWAS. You can see here that the most efficient speed, not surprisingly as we're told, is in the 50 to 60 mile per hour range, and it tapers off quickly after that. This second orange line is actually for the tailgate down condition. Someone once asked me, is it more efficient to drive with your tailgate up or down? Because I've heard it both ways. Well, turns out that you get a little bit better mileage, at least for my truck, in the tailgate down condition. But you can see that it pretty much joins up here once you get up to about 80 miles per hour. What's really nice about this whole thing is you don't have to actually design an experiment. You can just do a thought experiment or check the math. And that's really great because you don't necessarily then have to get into a spaceship and travel at 90% the speed of light for 3 years to find your answer. You just have to think about it for a second and check the math. It's really not all that difficult. Go ahead and subscribe if you haven't already. I'm Mike Thompson, and thanks for watching. I really appreciate it.